There's also lots to do with energy in longboarding. When a person on a longboard is in motion, they have kinetic energy. So kinetic energy is basically the energy of momentum. And an object that has motion always has kinetic energy. So here's the equation for kinetic energy. It's EK, which is kinetic energy, equals a half times it by mass multiplied by velocity squared. Energy an object possesses by its gravitational field position. Now the equation for gravitational potential energy is this one right here. It is basically saying that gravitational potential energy equals mass times the acceleration due to gravity multiplied by the height of the object. So as you can see here in the video, we start off with kinetic energy we start off with gravitational potential energy as we're up on a hill, and then as we roll down the hill, our gravitational potential energy is converted to kinetic energy because as we go down the hill, we build up velocity. And so because we're building up velocity, we're building up kinetic energy. But then as we're going down the hill, we're also losing gravitational potential energy.
So the next thing we're going to talk about is Newton's laws of motion. So Newton has 3 laws of motion. The first one is an object in motion is going to want to always stay in motion, just as we want to stay in motion when we're longboarding. And an object at rest is going to want to stay at rest. The next law is going to be F net is equal to ma. So the net force is always equal to the mass times the acceleration. And then his final law is every force will have an equal and opposite reaction. So just as the force of gravity has the normal force. So how these 3 laws of motion apply to our longboarding is, for the very first law, an object in motion wants to stay in motion, or an object at rest wants to stay at rest. We want to stay in motion while we're longboarding because we obviously don't want to stop going down the hill. Then the second law, basically we have a net force that's going forward because we have a mass and we have an acceleration going down the hill. So mass times the acceleration will get a vector going down. And then finally, the force of gravity and our normal force, it keeps us from falling through our boards, which is the third law. Yeah. Every action has an equal and opposite reaction.
Now, momentum is the last physics concept that we're going to talk about with longboarding. Momentum is very applicable to longboarding because it's the quantity of motion that an object has. So if an object has either more mass or more velocity, it has more momentum. So if, say, a 200 kilogram person got on a longboard and went down a hill, they would have more momentum than, say, a 100 kilogram person on a longboard. And this causes you to just cut that out. So the equation for momentum is written right here. What it's saying is that momentum equals mass times velocity, and it's measured in kilograms multiplied by meters per second. And this equation is very useful in solving for many different momentum problems. And as you can see in the video right now that's playing, our momentum is very great as we accelerate down the hill because we are fairly heavy people, and so therefore, since we have mass and we have velocity, we have a pretty decent momentum.
Okay, so longboarding started way back when everybody started looking like this guy right here. Look at that flow. Woohoo. Yeah. Alright, yeah, so the size of longboards can vary from anywhere from 24 inches to 80 inches. Ryan here has a 38-inch board, whereas I have a 40-inch board. So they can vary from any sizes. The sport really originated from surfing. People want to take surfing to the land, and that's how they got longboards. It also evolved from skateboarders. As they got older, they still want to skate, but skateboards are a lot harder to ride, and they're more harder on your body. So they invented a longboard, which is more flexy and easier to ride.